All right, gang, in this lesson of the unit circle lessons, we are going to discuss the Pythagorean theorem, review that a little bit, as well as talk about the trig ratios, sine, cosine, and tangent that you've learned from geometry. And we're also going to discuss their reciprocals, cosecant, secant, and cotangent. So quick recap of Pythagorean theorem. I know that you know the formula, a squared plus b squared equals c squared, and we use that typically to solve for a side length, specifically of a right triangle. So in our first couple of examples, we do have images. The next two, we're just going to be given the side lengths written down, and we'll solve for a given value. So remember, A and B represent the legs of your right triangle that create the right angle, and C is always representing the longest side, which is your hypotenuse. So in example 3, the two leg lengths are 5 meters and the hypotenuse is unknown. So we'll write 5 squared plus 5 squared equals x squared. 25 plus 25 gives us 50, and then when we take the square root of each side, the square root of 50 simplifies to be the square root of 25 times 2, which would be 5 square root 2. And we're only looking for the principal root, only looking for that positive value representing the distance or the length of the hypotenuse. All right, example 4. Even though the diagram is a little bit off kilter, still the leg lengths are the two that are given, the square root of 10 and the square root of 7. So we're going to do the square root of 10 squared plus the square root of 7 squared equals the hypotenuse squared, which is x squared. So square root of 10 squared reduces to 10. The square root of 7 squared reduces to 7. So x squared equals 17. And again, we'll take our square root. The length of the hypotenuse is the square root of 17. In our next two examples, we are given only the side lengths. We don't have a diagram. Remember, C is representing the length of the hypotenuse. B and A are going to be your leg lengths. So in example 5, B is the square root of 5 centimeters, C is the square root of 14 centimeters. So A squared plus the square root of 5 squared equals the square root of 14 squared. Just as we did in the previous problem, the square of a square root undoes itself. So we'll have A squared plus 5 equals 14. When we subtract 5 from each side, we'll have a squared to equal 9. And when you simplify, you'll get that a has a value of 3. So the length of the missing side is 3. And actually, we should be putting those units of measures on there, so 3 centimeters. Number 6, exact same setup, but we have B is 14 feet and C, the hypotenuse, is 15 feet. So a squared plus 14 squared equals 15 squared. And 14 squared is 196. So a squared plus 196 equals 15 squared, which is 225. When we subtract 196, that will leave us with a squared equaling 29. And when you take the square root, you determine the length of the leg A is square root of 29 feet. Good job. Good quick review. So the trig functions, or the trig ratios that you discussed in geometry, hopefully you remember them, are sine, cosine, and tangent. And the ratios for each of these, sine is the opposite over the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is the opposite side of the angle divided by the adjacent side of the angle. So we do have those original trig functions, sine, cosine, and tangent, and they have reciprocals. Remember, reciprocal is a big word for flip. So just take whatever fraction or ratio you have and change your numerator and denominator places, flip them upside down. So sine of x, x is just any angle, again, that is the opposite divided by the hypotenuse. It has a reciprocal called cosecant. Cosecant of that same angle will be the hypotenuse divided by the opposite. We'll look at a picture in just a moment to help us remember what opposite, adjacent, and hypotenuse represent. For cosine, that has a ratio of the adjacent side divided by the hypotenuse. Its reciprocal, which is nu, is secant, and secant's ratio will be hypotenuse divided by adjacent. And last but not least, tangent is the opposite side of the angle divided by the adjacent side. So its reciprocal is cotangent, and its ratio will be the adjacent divided by the opposite. All right, and real quick, just a picture. Draw yourself a right triangle anywhere. Here's my right angle. You can put X or theta. Remember, I like to use theta for my angle. You can pop that anywhere that you like. I'm going to put it in the bottom left corner of my triangle. The opposite side, so go across from the angle to get your opposite side. Adjacent means next to. So the next to is going to be the adjacent, which is going to be, in this case, that bottom part of my triangle. And hypotenuse is always across from your 90-degree angle or your right angle, so there's the hypotenuse. Okay, so that's what we're talking about when we're talking about the opposite and adjacent of some angle x or some angle theta. We're now going to practice some examples. Before we get to them, I want to quickly write down each of the ratios of our original three sine, cosine, and tangent trig ratios, and then their reciprocals. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cosecant, the reciprocal of sine, is the hypotenuse over opposite. Secant, the reciprocal of cosine, is the hypotenuse over the adjacent. And cotangent, the reciprocal of tangent, is the adjacent divided by the opposite. All right, we're going to have a right triangle, ABC, where C is the right angle. We're going to evaluate or find each of the trig ratios asked for. So in our triangle, we are looking for cotangent of angle A. So C has got to be the right angle. A and B can be the other two. Doesn't really matter where you put them. And it tells us that side C is 25. Remember, your sides are across from your angles. Side B is 7, so that will be that vertical. And side A is what I need to determine. If we're looking for angle A, we're referencing angle A here. So I'm going to go ahead and just quickly label opposite of side A is side A. Opposite of angle A is side A. Opposite of B is side B, so that's going to be the adjacent to A, and hypotenuse is going to be my 25. So in this case, if I want cotangent, cotangent is the adjacent over the opposite. So cotangent equals adjacent over opposite. I already have the adjacent side. Next to angle A is a length of 7. The opposite I do not have, so I'm going to have to do some work for that. Lo and behold, we're back to Pythagorean theorem. So a squared plus 7 squared equals 25 squared. 7 squared is 49. And 25 squared is 625. So when we subtract, we'll get a squared to equal 576. And when you take your square root, you determine that the value of a is 24. So we have determined that side A has a length of 24, which is opposite of angle A. So that will be our denominator for our ratio. Cotangent is the adjacent, 7, divided by the opposite, 24. There you go. Our next one, find cosecant of angle A if B is 20 and C is 25. So cosecant in this case is the hypotenuse over the opposite. Let's draw a picture and see what we have. Okay, so drawing our triangle, there's angle C, my right angle. Its side length is 25. Angle A I'm putting up at the top again, so side A is down at the bottom. Side B is opposite of angle B, has a length of 20. For cosecant of angle A, we need the hypotenuse divided by the opposite. And right now we only have the hypotenuse, which is 25. Again, we're going to have to solve for side A to find the opposite value. So a squared plus 20 squared equals 25 squared. 20 squared is 400. 625 is 25 squared. We just did that one. Yay us. So a squared will give us 225 when we subtract. When you take your square root, a has a value of 15. So now we can write cosecant of angle A is the hypotenuse, 25, divided by the opposite, which is 15. And it does simplify, so you should simplify cosecant of angle A as divide them by 5, so you'll get 5 over 3. And we've lucked out in both of these first two examples. The Pythagorean theorem gave us exact values. We are going to write down some Pythagorean triples in a few moments as we go through some more of these. So example 11, find tangent of angle A if B is 3 and A is 4. So sketch our triangle, help us out. Side C is unknown. Side B is 3 and side A is 4. And again, for tangent of angle A, we want opposite over adjacent. So if I'm looking at angle A, I have the opposite side, it's 4, and I also have the adjacent side, it's 3. So in this case, we don't have to do Pythagorean theorem. Now you could solve and find that the length is 5 for the hypotenuse, but it's unnecessary. So save yourself a little bit of work. Tangent of angle A is 4 over 3. There you go. And again, Pythagorean theorem is 3 squared plus 4 squared equals c squared. 9 and 16 give us 25. So 25 would equal c squared, so c does equal 5. Just a quick check for those of you that like to know for sure it works. All right, number 12, let's find cosine of angle A. That's one of our originals. Cosine is always going to be the adjacent over the hypotenuse. Adjacent over hypotenuse. All right, draw our picture. We have angle C is in the bottom right corner at 90 degrees. Side C is 11. Angle A is at the top, so side A 10 is at the bottom. And B is side B. We don't know. We're going to have to solve that one. So Pythagorean theorem, b squared plus 10 squared equals 11 squared. 10 squared is 100, 11 squared is 121. So when we subtract, we get b squared to equal 21. And when we take the square root, it doesn't simplify. So our b value, the adjacent side, is the square root of 21. Okay, in order to find cosine of angle A, I need the adjacent side, which is the square root of 21, divided by the hypotenuse, which is 11. And there you go. We're getting there, gang. Good job. A couple more of these, and then we'll move on to a little bit different way of solving them. Find sine of angle A if C is 15 and A is 9. Angle C, so side C is 15. Angle A is at the top, so side A is at the bottom. Angle B I don't know, so side B I don't know, so I'll put a little b there. Again, we're looking for sine of angle A. That is always the opposite over the hypotenuse. With respect to angle A, I have the opposite side. It is 9. And we do have the hypotenuse. It is 15. So again, we lucked out. We don't have to do any work other than simplifying that ratio. Sine of angle A, 9 over 15, would be 3 over 5. Alrighty. Just if you wanted to know, B would be 12. All right, moving along, here's a new one, secant of angle A. So secant is the reciprocal of cosine. Cosine's adjacent over hypotenuse, so secant is going to be the hypotenuse divided by the adjacent. Let's draw ourselves our picture, see what we have. Side C and angle C. Okay, so C is 17. Got that one across from 90 degrees is hypotenuse. Angle B, so opposite of it would be side B, which is 8. Angle A, we don't know. So we need the hypotenuse and the adjacent. So with angle A, let's see what we have. We do have the hypotenuse at 17, and we do have the angle adjacent. It's 8. Yay us! So secant of angle A is 17 over 8. You got it. We don't have to simplify that one. Thank goodness. All right, I do want you guys to jot down some Pythagorean triples before we move on to the next part. These triples you will see used over and over again, and there will be multiples of them. So we have a 3, 4, 5 triangle. 3 squared plus 4 squared is always equal to 5 squared. Another one is a 5, 12, 13. 25 plus 144 equals 169. Two others that we use are a 7, 24, 25. 49 plus 576 does equal 625. And the last one you'll see from time to time is an 8, 15, 17. So 64 plus 225 equals 289. There's one other one that we see sometimes, a 9, 40, 41, but those numbers get pretty large and we try to keep things a little bit smaller when we're dealing with these, just so you guys understand the concept and not have to get bogged down with the math. All right, here's our next little chunk. These are written in just a little bit of a different format, but we're still going to be doing the same work. We're going to be using the ratio that's given to help us find another one. Okay, so in number 15 we have find secant of theta if cosine of theta is the square root of 17 over 17. All right, if you remember that cosine is adjacent over hypotenuse, great, thumbs up, good job. The next thing is, did you also remember that secant and cosine are reciprocals? So if I know that cosine is adjacent over hypotenuse, then secant of theta, it's going to be its reciprocal, hypotenuse over adjacent. So all we have to do is just take the given values for cosine and flip them upside down. So secant of theta is going to be 17 divided by the square root of 17. Now here's where the trick comes into play. We need to rationalize so that we don't have a radical in the denominator. So multiply both by square root of 17 in the numerator and denominator. So 17 multiplied by square root of 17 is 17 root 17. The square root of 17 multiplied by itself is 17. Those will reduce, just leaving us with a value of square root of 17 for secant of theta. Pause and rewind if you need to see that again. All right, number 16, cotangent of theta. Remember, cotangent is the reciprocal of tangent, and if tangent is opposite over adjacent, cotangent is adjacent over opposite. For sine of theta, that is the opposite over hypotenuse, so we're going to have to do a little bit of work to help us determine the cotangent of the same angle. So we're going to sketch our triangle. Doesn't matter where you put your theta. I'm going to tuck it in the bottom right corner here. Sine is the opposite, so 4 square root 7 is opposite of theta over the hypotenuse, which is across from or opposite of 90 degrees. We do need to do Pythagorean theorem to solve for the length of the adjacent side. So 4 square root 7, that quantity squared, plus b squared equals 11 squared. 4 squared is 16, the square root of 7 squared is 7, and when I multiply those two values together, I get 112. 112 plus b squared equals 121, so b squared equals 9, and b equals 3. Now that we have the adjacent and the opposite sides, we can determine the value of cotangent of theta. The adjacent side is 3. The opposite is 4 square root 7. We do need to rationalize again, so we'll multiply by root 7 in both numerator and denominator. And when you simplify, you'll have 3 square root 7 for the numerator, and 4 multiplied by the square root of 7 times itself is just 7. So 4 times 7 in the denominator is 28. So cotangent of theta for that particular angle is 3 square root 7 all over 28. Again, both of these did rationalizing denominators, so if you need to practice that again, make sure that you go back through and review this section. We might have another one as we go through. Let's see. All right, number 17. Find cosine of theta if tangent is 4 over 3. All right, I'm going to draw myself a picture. It's going to help me. I'm going to put theta down in the bottom. I know that tangent is the opposite over the adjacent, so opposite of theta has a value or a length of 4. Adjacent or next to has a value of 3. And we're going to do 3 squared plus 4 squared equals c squared, or the hypotenuse squared. Oh, that's one of those triples. That's a 3, 4, 5. So 9 and 16 is 25, and we do get that the square root of 25 is 5. Good job. So we found our hypotenuse length to be 5. Now we can write cosine. Cosine of theta is adjacent over hypotenuse. So cosine of theta, adjacent is 3, hypotenuse is 5, so 3 over 5. Not too bad. All right, next example. Sine of theta, determine that value. Given cotangent is 24 over 7. All right, so we got to know what cotangent is. Remember, reciprocal of tangent. Tangent is opposite adjacent, so this is adjacent over opposite. Okay, draw ourselves our picture. Theta, opposite, nope, I want to go adjacent, excuse me. Adjacent, 24 will be next to theta down on the bottom for my picture. Opposite of that angle will be 7. We do need to know the hypotenuse for sine, which is the opposite over hypotenuse. Alrighty, so let's do some work. 7 squared plus 24 squared, oops, my pen is acting silly, equals c squared. That's another one of those triples. It's a 7, 24, 25. Let's double check. 49 plus 576 equals 625. And when we take the square root of 625, we do get 25. Good deal. All right, let's go back and determine sine of theta. So sine of theta has to be the opposite side, 7, over the hypotenuse, which is 25. Good job, guys. We are on the last two examples. Here we go. We're given cosecant of theta, and we have to determine tangent. So cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Sketch our picture. Hypotenuse is going to be square root 17, and opposite is going to be 4. We are going to use Pythagorean theorem to solve for the missing side length so that we will have the adjacent value next to theta. 4 squared plus b squared is the square root of 17 squared. So 16 plus b squared equals 17. If b squared equals 1, then b equals 1. My goodness, that is so nice. Love it. All right, let's find the value of tangent of theta now that we know both of the sides. Again, tangent is opposite over adjacent. Opposite of theta is 4. Adjacent value, that side length is 1. So tangent of theta is just 4. And here's our very last example. Here we go. Find cosecant. We just did that. That's hypotenuse over opposite. If the tangent, we just did that one too, is 4 over 3, opposite over adjacent. So again, we're going to have to find hypotenuse. That's okay. We can do it. We've been doing it all day. Here we go. Triangle, right angle. For theta, the opposite side is 4. The adjacent side is 3. And remember, that is a 3, 4, 5 triangle, so our hypotenuse should have a value of 5. If you are just a person who has to see it to prove it, you gotta see all the work. 9 plus 16 is 25, and its square root is 5. There's Pythagorean theorem. All right, now we're going to find cosecant. Ooh, my pen's not writing. Cosecant of theta. So for cosecant, I need the hypotenuse divided by the opposite. The hypotenuse is 5, the opposite is 4. Cosecant of theta for this last example is 5 over 4. Great job, everybody. Make sure that you are practicing some of the examples that are on the following worksheet in your packet, worksheet C, and have a great one.